looking at this, how do we always start? Given. Very good. Given. So number one, that was a given information. Sure enough, when you look over, that was given. Number one is given. Then they say DEG is congruent to GEF. Well, if I look at what was given, EG is a bisector of DEF. DEF got bisected. That meant that this angle is equal to this angle. If I want to mark it in my... And that is a definition of bisector. Now that I look back at this and I have DEG and GEF. Definition of bisector. Good. Thank you. Definition of bisector. Then number 3, if those are congruent, their measures are equal by what? Charlie, you still with us? Yeah. Okay. So what is that? Congruence, measures are equal. What's making the measures equal? The fact that they were congruent, which is the definition of congruence. Now they said 5x plus 10 equals 6x plus 4. Well, I haven't seen anything here or here that would give me that. But if I look over in the picture, DEG is here, which is this. And GEF is this angle, which is that. So I just put that in, and I put that in. That is what? Substitution, right? I just substituted in, given the information in the picture. I'm dealing with equations, so it's property of equality. Now what? Now, it's algebra, right? What'd they do to both sides? Yeah, they minused it, which is subtraction. Subtraction, property of equality.
Could you, for number 4, could you also say the definition of bisector?
No, because we use the definition of bisector to get the two angles
oh, so you can't use this
congruent. No, you can use more than once, but in this case, we've gotten this, and then we've done a nice job changing it to a measure, and then taking the measure from the picture and substituting it in. So I like the steps that they took. It's a very nice broken down. Now some people might have gotten this and jumped right to this. It's a little sloppy when it comes to a proof, but Charlie, I totally agree with you. It's not necessarily a obvious steps. But I do think these steps are justified. So we would want to use those. So we use the subtraction property of equality. Then how do we get from step 5 to 6?
Yeah, same thing.
Subtraction again. We subtracted 4 this time. Instead of 5x, now we're subtracting 4. Subtraction property of equality. And then why is 6 equal to x, x equal to 6? Reflexive property. Reflexive property of equality. Very good. Okay, we don't have a lot more time. Let's go ahead and flip this and see where 1 and 3 are vertical angles. That was the given, as usual.
Mr. Z,
Yes.
I think 7 is symmetric property.
Oh, is it? Uh-oh. Uh-oh. Let me look at my sheet. Those are the ones that I get sloppy on. I would be checking that. So it is symmetric. Reflexive is when reflexive, I always try to think, and after a few times I will. Reflexive is when it's like a reflection in a mirror. It's exactly the same. So this is symmetric. Hey, we still have 5 minutes. Let's make sure we get this one down in the books too and make sure we have it right. On this problem, we said these are vertical angles. 1 and 3 are vertical angles. Then they said 1 and 2 equal 180. Why is the measure of 1 and the measure of 2 equal 180? Linear pair postulate. And same thing for 2 and 3. Those are a linear pair postulate. Then the next one, well, we're basically substituting in this for the 180, so it's substitution property. Now, how'd they get from 4 to 5? It's straight up, just right there. We're not going to go above or look at the picture. We're just going to say, if I know measure of angle 1 plus measure of angle 2 equals the measure of angle 2 plus the measure of angle 3, then 1 must be equal to 3. Why is that? Not transitive.
Why?
What do? We got rid of what? The same thing on both sides. How do we get rid of both things? Subtraction property, right? Subtraction property of equality. And then the last one, the fact that the measures are equal, the two angles are congruent by definition of congruency. Good.